For as long as humans have existed, we've needed to count and calculate. Early humans used their fingers and toes, but this method was limited. Then came tally sticks and knotted cords, simple tools for recording quantities. Around 3000 BC, the abacus emerged in Mesopotamia. This ingenious device with beads on rods allowed for more complex calculations. The abacus was widely adopted across Asia and Europe and remained a vital calculating tool for centuries. The abacus wasn't just a tool for merchants and traders, it played a crucial role in the development of mathematics. By physically manipulating beads, users could visualize mathematical concepts in a tangible way. This hands-on approach to calculation laid the groundwork for future advancements in computing. The abacus proved that humans could create devices to aid in complex computations. This set the stage for even more sophisticated calculating machines in the centuries to come. Fast forward to the 19th century, a time of great industrial and scientific progress. Charles Babbage, an English mathematician, envisioned a machine that could perform calculations automatically. He called it the analytical engine. Babbage's design was revolutionary. It included input devices, a memory unit, a control unit, and output devices. Although never built in his lifetime, Babbage's ideas laid the foundation for modern computers. The mid-20th century saw the convergence of mathematics, engineering, and electronics. These behemoths, like the ENIAC, were massive machines. ENIAC, completed in 1945, was used for calculating artillery firing tables. UNIVAC was used for business applications, like payroll processing. Pioneers like Alan Turing and John von Neumann made significant contributions. The invention of the transistor in 1947 at Bell Labs revolutionized the world of electronics and, in turn, computing. Transistors could perform the same functions as vacuum tubes, but were much smaller, more reliable, and consumed less power. This paved the way for smaller, more powerful computers. The impact of the transistor cannot be overstated. It was a key factor in the development of the integrated circuit, IC, in the late 1950s. An IC combined multiple transistors and other electronic components on a single chip of semiconductor material, usually silicon. This miniaturization of electronics led to a dramatic decrease in the size and cost of computers, while simultaneously increasing their processing power and efficiency. The era of mainframe computers, which were large enough to fill a room, was gradually giving way to smaller, more accessible machines. Section 5, the microprocessor, a tiny chip with giant impact. In 1971, Intel, a company at the forefront of the semiconductor industry, introduced the 4004. This was the world's first commercially available microprocessor. A microprocessor is a complete central processing unit, or CPU, on a single chip. This innovation marked a pivotal moment in the history of computing. The microprocessor effectively put the power of a computer onto a chip the size of a fingernail. This paved the way for the development of personal computers, which would soon become ubiquitous. The microprocessor revolutionized not just computers, but also countless other devices. From calculators and watches to cars and appliances, microprocessors became the brains behind countless electronic devices, making them smarter and more functional. Section 6. The rise of personal computing, from hobby kits to household staples. The mid-1970s saw the emergence of personal computers, or PCs. These early PCs, often sold as kits, were targeted at hobbyists and electronics enthusiasts. Companies like Apple Computer, founded by Steve Jobs and Steve Wozniak, popularized the idea of a personal computer that was easy to use and accessible to everyone. The introduction of the Apple II in 1977 was a watershed moment. It was one of the first successful mass-produced personal computers and helped bring computing into homes and schools. The graphical user interface, or GUI, which used icons, windows, and a mouse, made computers more user-friendly, especially for those who were not tech-savvy. The development of software for these early PCs, including word processors, spreadsheets, and games, further fueled the adoption of computers. The PC revolution had begun, and it would transform the world in profound ways. Section 7. The Internet Age, connecting the world, one computer at a time. While personal computers were rapidly evolving, so too was the way we connected them. The Internet, initially a network for researchers and academics, began to grow at an astonishing rate in the 1990s. With the development of the World Wide Web and the first web browsers, accessing information online became easier than ever before. The Internet's impact on society has been profound, transforming how we communicate, learn, work, and entertain ourselves. Email became a ubiquitous form of communication, and the Internet made it possible to access vast amounts of information from around the globe. E-commerce emerged as a new way to shop, and social media platforms connected people in ways never before imagined. The Internet's ability to connect people and information has had a profound impact on globalization, fostering collaboration and cultural exchange on an unprecedented scale. Section 8, the mobile revolution, putting powerful computers in our pockets. The 21st century witnessed the rise of mobile computing. Smartphones, equipped with powerful processors, high-resolution displays, and internet connectivity, became ubiquitous. These pocket-sized devices essentially put the power of a computer from the 1990s into the palm of our hands. The development of mobile apps for a wide range of purposes, from communication and social media to productivity and entertainment, further fueled the adoption of smartphones. Mobile devices became indispensable tools for communication, navigation, entertainment, and much more. The rise of mobile computing led to the development of new technologies like mobile payments, location-based services, and augmented reality. Smartphones have become an integral part of our daily lives, fundamentally changing how we interact with the world around us. Section 9. Artificial intelligence making computers think. Artificial intelligence, once a concept confined to science fiction, is rapidly becoming a reality. AI involves developing computer systems capable of performing tasks that typically require human intelligence. These tasks include learning, problem-solving, and decision-making. Machine learning, a subset of AI, allows computers to learn from data without explicit programming. This has led to breakthroughs in areas like image recognition, natural language processing, and predictive analytics. AI is being used in a growing number of applications, from self-driving cars and virtual assistants to medical diagnosis and financial trading. While AI holds immense promise for solving complex problems and improving our lives, it also raises ethical concerns about job displacement, privacy, and the potential for misuse. As AI continues to advance, it's crucial to consider its impact on society and ensure its responsible development and deployment. Section 10. The future of computing, a world of possibilities. The evolution of computers continues at a breathtaking pace. Quantum computing, which harnesses the principles of quantum mechanics, promises to revolutionize computing. It has the potential to solve problems that are currently intractable for even the most powerful supercomputers. Cloud computing, which allows users to access computing resources over the internet, is changing how we store, process, and share information. The Internet of Things connects everyday objects to the Internet, enabling them to collect and exchange data. This interconnectedness is leading to smarter homes, cities, and transportation systems. The future of computing is likely to be characterized by even greater miniaturization, increased processing power, and seamless integration of technology into our lives. From wearable computers to implantable devices, the line between humans and technology is becoming increasingly blurred. As we continue to push the boundaries of what's possible with computers, we can expect a future filled with both exciting possibilities and challenges that will require careful consideration and ethical decision-making.